here. I suppose there are no virus. Uh, yes. Shall I copy it on desktop?
Yes.
Okay. Just in case, I will put it in download. Is it okay?
Yes.
Okay. And I'll keep open. Yes. Yes. Okay. Yes. So yes, we are now in Microsoft Pro. So, yes. Thank you, Sunday. So you're from? You're from? So I'm from Sri Lanka. I'm a student in here. No. Yeah.
Yes.
First round. Okay. Okay. Yes.
Our presentation file.
Yeah, sure.
Is it your PC?
Yes.
So how can we send you?
My Udaka 21.
Good morning.
21 at gmail.com.
Yes. Dependency.
So I'll take some photos and give it to Professor Roy.
Where are the member would you, but it's not for me.
Yeah, it's good. Professor Gobi, can you hear me? I think I turned out my headphone. Same as. Professor, can you hear me? Yeah, it's EAR.
Mr. Udaka, you are not audible.
Can you hear me, Professor? Professor Gobi? Just wait.
Hello, can you hear me?
Yes, we can hear you. So, I'm Udaka, a student, University of ISU, and I'm handling the technical issues in the physical space in University of ISU. So, yes, I will wait until the period where is over. Okay. Yes. So, good evening, everyone. Good morning or good afternoon. So we are in breakout room 2. So the session chair is Professor Gopi from India. So I'm hand the session to you, Professor.
Yeah, thank you. Thank you for the introduction, Professor. We are good to go ahead now.
Yes, we are good.
Yes. Yeah, to introduce others, myself Gopi from Christ University, India. Thank you for joining. Just a minute. Yeah, everything is set up now. Sorry for the interruption. We are good to go ahead now.
Yes, yes. Here it's okay.
Am I audible, Mr. Budaka?
Yeah. I can hear you. Sure. Can you hear me?
Yes, but the voice is very feeble.
Uh-huh. Can you hear me now?
1 minute. Can you speak now?
Yes. So can you hear me?
Yeah, this is perfect. Yeah.
Yeah, sure. Okay. So now you start. Now you can start, Professor.
Okay. I think is there other participants who are here in the room?
Yes. Some of them are in University of ISO. Especially, I think for first four participants, three participants are in here.
Okay, that's perfect.
Present.
Let us go by the order. Yeah, I'll start now. Yeah, to introduce the participant. Thank you for joining. This conference in association with the other bodies, Christ University, uh, joining in this the third year. This is 3.0 from the Christ University. This one we have been associating for this conference in collaboration, delivering talks, and being the session chair. This is about the small intro about Christ University and the University of Azu, Japan. And this aims, collaborating and global networking, especially in the field of ELTC and then ICT for global education, especially in science and technology education. With this limited introduction, we would like to proceed for this presentation. We'll go by order. Just two things. Please stick on to the time schedule. When it is about to end, we will give an, we will interrupt your session if you're exceeding the limit. And there should be some time for, in general, it was 15 minutes for the presentation and 5 minutes for the question and answer. Thank you for your understanding. Now we'll go for the presentation. First, I'll introduce this paper ID 4304. Mr. Professor R.H.R. Sankha and et al. The topic is development of unmanned aircraft system for disaster environments. Yes.
So, Professor, so it should be session 2. Sorry, session 6 from January 25th. So the first presenter is in here is Ahmed from yes.
Just a minute. Yeah. Just a minute. Yeah. The 1 minute. The first session is Ahmed Azani.
Yes.
An autonomous system for Arabic traffic signs recognition. Am I correct?
Yes. So he will present you on this computer because he's in here. Okay. Yeah. You can. Good afternoon, everyone. Thank you for having me. Thank you for Dr. Gabi for his introduction and for the assistance as well. My topic today is an autonomous system for Arabic traffic signs recognition. What I'm trying actually to do is to build a system that is specialized for Arabic traffic signs and assist drivers and pedestrians to take care of their
journey. Because of that, this is a big project, but
sorry for interfering. This presentation, it is in the presenter mode. Actually, we could be able to see the next slide as well.
Okay. Convert it to PDF. No, just like. No.
Yes, this is perfect now.
Yes. Okay. So you can see.
Oh, you have.
Yes.
Yes. Okay, I can see that. So I will start with the introduction, and we will see why we are doing that. Are you okay? Okay. And then we will do the analysis of the road signs recognition methods. And we will give an introduction also to a brief about the study of the system and learning procedures, see the results, and we will conclude and see future work. This is uncompleted work, and we will continue after this presentation as well. We know car accidents are caused by several factors. One of them is drinking, driving recklessly, but most importantly, people fail to recognize signs and they ignore it. And traffic signs are usually visual aids that provide information to drivers and pedestrians to avoid, for example, slippery roads or any other issues. Because of that, European countries, they standardize the traffic signs, and they try to make a unified system. And our Ministry of Transportation follows that and classifies traffic signs into three categories, two big categories: horizontal and vertical. The vertical signs are categorized into three categories: restrictive, which is with red and white, usually for stop signs and the speed limit; and preventive usually comes in blue, comes in yellow and black, like slippery roads and falling rocks. The third one is the informative, like the sign of hospital, usually comes in blue. But we have a problem that traffic signs varies based on languages. Here is I cannot read the signs because it's written in kanji, I think in Japanese. And in our country as well, you cannot read it because it's in Arabic. And also there are some special signs. I think we have in GCC countries, the camel sign, similar with in Australia, they have kangaroos, and in USA, deers, and some other countries, they may have cows. So what's our contribution is we start collecting data, and this data contains Arabic signs localized in my country, in Saudi Arabia. And we have also a methodology for detecting and recognizing Arabic traffic signs in various environments. If we look into what other people have done, so we can summarize them into two big categories. They either use the classic neural networks or the convolutional neural network. For the classical neural network, it is usually 3 layers: input layer, hidden layer, and the output layer. So basically, you take an input, weight, multiply it with a weight vector, and apply a bias, and then map it through activation function, usually a hypertangent or sigmoid function. That output is called the predicted output, and you compare it to the actual output or the labeled output. And based on that, you try to minimize the error and improve the learning curve. Similarly, with the convolutional neural network, only we added more hidden neurons. We have something called local perceptrons. We just use specific areas, and we have shared weight and subsampling to reduce the size and the dimensions. The overview of our system is basic. We started collecting images, and then we trained the convolutional neural network with CFAR 10. CFAR stands for Canadian Institute for Advanced Research. This is a database, is famous, you can download it online. And we have done that for a reason, we will tell you later. Then we train for recurrent convolutional neural networks. So in this step, we don't detect what inside the signal, the sign. We just see if there is a sign, a traffic sign in the picture or not. If there is a traffic sign, then we go to the last step with the classification. We see what's inside that step, what's inside that traffic sign. So for image collections, we take samples of 3 types of vertical traffic signs. So we took from the preventive, the stop and yield and speed limit. And then we have also from the informative, the hospital and disabled parking. These are the total number that are original, the unique picture. The image captured in Najran, in my city, in the southern part of Saudi Arabia. So we had unique more than 200 color images at first phase with this dimensions, 900 multiplied 1200 pixels, and 675 width and 900 pixels. So for the image collections, it's very hectic job and it is difficult job to do. We have low number of images. So in order to do augmentation, we have taken the pictures from different angles and different illumination and different weather conditions. Before we apply we do the training, we need to pre-train the neural network. Why? Because we need to detect edges, detect trucks, and to have informative. When we see the road, we see more than the traffic signs. So we have implemented this network and train it with the CFAR 10, which is downloaded. It contains 50,000 32 by 32 pixels RGB images. These images include animals and trucks. So we have image input. Then we started to do the convolutional layer, rectified layer, linear unit, and then we do max pool, repeat that again, and repeat that again. and then we do fully connected layer, then do rectified linear unit, and then we do softmax to convert the numbers into probabilities. And see, and then classify the output. Then we do the train, the recurrent neural network. We use the output from the previous step, which is weight vectors, and then add knowledge to already trained network. The first step is to find a subset of the areas in the image that might contain an item. So basically, we are trying to see what inside, if the image contains traffic sign or not. If yes, then go to the second stage and do classification of the recognized object. For recognition, we just we have something called ResNet, residual neural network 50. It's famous and it is standardized. It's in you can find it in MATLAB. So we just edited the last 3 network, and we got better results than ResNet 50. For the result, we had many images for training, but this is for test. So for stop signs, which is the most difficult traffic signs to recognize, we had 48, and we couldn't detect 3 of them. Then for the no U-turn, we had missed 1, and also 1 for the roundabout, and for the slow school ahead, we missed also 3. So based on this results, we had also tried to do live demo, but we couldn't bring it today. We had about like 95% accuracy, and we can improve that. We cannot stay at this percentage. We need to improve it more. For the conclusion, we presented an intelligent approach for recognizing and identifying Arabic traffic signs using convolutional neural network and recurrent neural network. The results of experiments, it was observed, proposal obtains accuracy of more than 95. But we cannot stop here. We are continuing. We are trying now to take the output neural network and apply it on low-cost hardware. So with something called, it's not Arduino, it's something similar to a Raspberry Pi. If we could do that, and we do like demo, this is a first milestone, but I think it's really computationally expensive. We cannot do that easily. We need to do some tricks. That is our work. And if you have any question, thank you. And if you have any question, you can email me. You can ask now. If you want to collaborate as well, just email me. Here is the references I used. Some of the references, there are many on the paper as well. If you have any question, please.
Yeah.
Thank you.
Audience, do you have any questions on this?
You think you are going to
Implement this?
implement.
Yes.
So what kind of hardware you are using?
We have something called PyKit, something with Python, and it's similar to Arduino, but it's more, has more capability than Arduino. but I don't think we can do that for a large data, I mean, for a large network, because it's difficult. It takes time. There is something called Judson, I think,
Yes.
but it's expensive. This is not,
Yes.
yes, there is not. Yeah, thank you so much.
Uh, just I have a curious question. I'm very happy to be part of this, and then this particular work, especially a country like India, it will fascinate very much when we are automate things. Is it tested in real environment, especially at the university or any public setup? Is it you have any plans, Professor, for implementing this?
We have done it so far on MATLAB live. So we have live demo on MATLAB, but we
Okay.
cannot, we couldn't do it on the hardware. It is not an easy job to be.
Yes.
It is easy if I use the one that suggested, the Judson by NVIDIA. Yes, this
Yes.
can be, but it's not. It is expensive one.
Okay, as a prototype, it can be tested in a university setting where we will have a limited constraint. Then we will have a big scope for research as well to take it into the next level or in the live project maybe later.
Yes, that is a really good topic for hardware engineers, and also for people who do optimization for coding as well. This is we should rely on software engineers for this one to implement the code, because the limitations of the hardware is of the low cost hardware is there, and our main objective is to implement it on a low cost hardware. Thank you for your suggestions, and we are happy to if you are going to collaborate in future. Thank you. Any other questions? Go.
Any other questions?
No other questions. Do you have any question? No, that's it.
Yes.
Okay, thank you.
Yeah, thank you. We'll go to the next presentation. The paper ID is 1690. The work is the artificial intelligence on cloud platform for cyber security using light GBM model through NIST cyber security framework. It will be presented by Nita Steman and Pongfest and Wukil. We welcome you for the presentation now.
So she's also in here, Professor. Just wait.
The presenters will be joining virtually or?
No, she's in here. So
Okay.
I'm going to help her.
Yes, please.
Sorry. Yes. So can you see the screen?
Yes, I can.
Okay. Okay. You can help.
My name is Kanika. I'm from Thailand. I have a topic to talk today is about the artificial intelligence on cloud platform for cybersecurity using YGBM model to NIST cybersecurity framework. So now I am to present. Okay. Okay. My agenda is about introduction, related work, research methodology, conclusion, and reference. My abstract is a very shortly about to summary with my research because nowadays in Thailand have some about research topic the most of AI. So I think have many research about AI, but I think I can take some framework for cybersecurity to apply for take some procedure or anything with cybersecurity. So my topic is about AI on cloud platform, and I have some about data set is a free and how I have a platform is a free open source. Okay, that some data set I will can use on H2O platform. Okay, that my topic have a related work about AI, machine learning, deep learning, and needs of cybersecurity framework. So it's about I apply this framework to research with one step. One step is about identify in the step I will shoot some data set and then I prepare link to select some data for next step is a project. Project is about execute to with a item or something to attract on how and then for next step I will to analysis about how cyber security is normal or not, and next step to respond on how platform, and the last step for recovery. These are framework of NIST so that I think is okay for to take my research finish and have some benefit for cybersecurity. So I want to show about this table on the screen to analysis about function category with our NIST framework. One function identify and category and AI cartoon how I define the problem. Each function identify I select data set and access management, which are category first, business, environment, governance, risk assessment, and risk management strategy. This is all on cloud. The function of a project category is about identify management and access control, awareness and training, data security, information protection, process and procedure. This is all on cloud is the same first step. And detect function have a category about analyze and event security, continuous monitoring, detection process. This is have some security and detection process on cloud, but can to improve about analyze and event on cloud AI. This is my check on AI cloud platform that I use to research. For response function, category about response planning, communication analysis, mitigation, improvement. That's all have on cloud AI, but don't to can't improve when have some attract on cloud is not can improvement immediately. And the last recovery planning, improvement, communication is all on cloud to present. So this that my preparing to take a research. I have some true data set for prepare. The first I have to data set is all I take from the free platform, and I have some choice data to select for source data. So I have to data set. And next to create visualization with a different data set, and next is I train about data set. If data set we can select that AI use live in model is to classify is working for many data, and next to experiment and prediction and create pipeline. The last step to deploy local or on cloud platform. This workflow I use by on cloud AI is so step seem look like easy. So, but this paper I focus on TCP sync to attract packet on cloud server to analysis about how the system prediction, classify, respond, identify, and the last can do about AI can learning and notify with admin system or not. So these are related work. When I put some data set on the system, the AI can show like this graph. We can select some graph or different graph when we want to know or analysis. How about TCP sync attract or by source, by destination, by depth, or anything we want to know. And then these are correlation graph is a show about when we use the sum x and y to analyze it with a light GDM model. Light GDM model is a high performance framework for decision algorithm to making classification regression. And when we training model with a everyone feature with light GDM achieved with a RMS of 7.2305. So data set show is like value on this graph. This algorithm is a best for AI model. I think is a good to apply for any case to analyze it with our cyber security for anything. Okay. For the last result is can cost together graph data value is a seem look like high percent if you see the graph. The graph positive for relation graph have score of one show is the finger like that. Okay, this have when more 90% score assure and predict. So this is what graph for result when we want to know the result to TCP sync attract this system AI on cloud is look like the point on graph you can see is okay for the breadth with a light BMP model. Show that for my conclusion, the AI cloud is the best for now to apply research and analysis with our cyber security for attract or man in the middle or software Trojan, everything we can find solution for protection the system. And this model is best for we use many data is to save some bandwidth or power to and may for we use classify. Okay, that's all for my presentation. This is my reference. Thank you.
Thank you for the presentation. Questions from audience? Any questions?
No.
Yeah. That's interesting work. My question is, if you're looking at the work, it has three important area. One is artificial intelligence, the other one is cloud computing, and the last one is cyber security. Okay, it's a three big area which is contributing to this research work. What are the limitations or drawback of your research?
Breakout.
Yeah, the limitations or drawback of your research work, I'm asking.
No, I can understand.
Yes.
What are the problems you found? What are the problems?
My problem is about friend.
Problems you found when you are doing this research?
Oh, no, I don't have any problem because the platform on cloud or AI cloud platform is I think is a perfect solution for use. With open source data set is free. Who can download anywhere for to research and analysis. I no problem with my research, but I can summary is the way for AI on cloud platform with a model like like GDM model is the work best because state many things with environment with a hard work of system is a take so a little to power to use for analyze. Okay.
Okay. You understood my question. The drawback or limitation of your research work?
No, I don't understand. What?
Negative. Negative.
Negative. No, I think positive.
Yeah, I have kept in the chat window as well. If you look at the chat window.
So limitations of your research work, drawbacks of your research work.
I think so.
Here, there. No, after that, limitation, yes, yes. Yes, yes. I think Professor has some language problem. I'm
Totally.
Okay. It's a global scenario now. Yeah.
The last question for drawback is research, right?
Yes.
yeah.
Okay. So my
It's okay. Yeah.
The answer I think is for to process on my organize and I work. Okay.
Okay.
Yeah.
Fine, thank you. Yeah.
Thank you.
Yeah, yeah.
Yeah. Shall we go to the next presentation?
Yeah, sure.
Yeah.
Sure, Professor.
Yeah. Am I audible? I mean,
Yes,
things
sir.
are clear.
Yeah, clear. Yeah. There are some, I think, language difficulties.
Yes. Yes.
Yes, so
Obviously.
presenter is also in here, so I will go to his computer.
Okay. The next paper ID is 2498. The paper titled 5G network combined with IoT for elderly home care. This is will be presented by Kabir and et al. Over to you now.
Yes, he's in here, so I will move to his computer.
Okay. You have to give presentation rights as well.
Yeah, if it's possible.
Yeah, you are visible now.
Is it okay?
Yeah, your screen is also visible now, but it is not in presentation mode. Yeah.
Uh,
No, still it is not in presentation
Yes.
mode.
So,
No, your screen is not visible to me.
yes, I think now it's okay.
Yeah, now it is visible. Yeah, please go ahead.
Hello, Professor. Hello, everyone. So, my name is Kabir, and I'm a student of ISO University. And we are presenting here about 5G network combined with IoT for elderly home care. And it will be a group presentation.
Not yes. Okay.
Suddenly the volume has come down. Yeah.
Professor, can you listen us?
Yes, now it is clear. Please go ahead.
Hello,
Yes.
Professor, can hear us?
Yes, I can hear.
I cannot hear anything.
Please proceed.
Yes, I can hear. Okay.
Okay.
So we are here to present about 5G network combined with IoT for elderly home care, and it will be a group presentation. We are 5 members in our group. So let's go to our next content. This is about content, and here I will describe about the motivation and the goal of our project, and about 5G technology, and how 5G technology how 5G technology is essential for elderly home care people. And in the later part, we describe about describe about our project by SWOT analysis, and some one of the present how it is reached the Isoka city. Those we live in Isoka now, and some then in the later part, our another brother will describe about the what kind of technology can be used in this Isokamatsu city, and final part goes by our brother where he also discuss about some survey review. So actually, one of the uh, entrepreneurs from America, and his name is Jim Rohn, who told that one person caring about another represents life's most significant value. Yes, I think it's one of the uh, uh, greatest thing to do, because who actually uh, built us such a beautiful country, such a beautiful world, doing for them something good. And that's why we actually select this topic, because hydropower city where aging rate is very high, where where the Japanese national aging rate is 28%, here Isokomatsu aging rate is 31%, which is higher than the national average. So here our goal is to make an overview of Isokomatsu elderly care system, and to suggest some devices which can be used in the Isokomatsu home care system, and they use it for their vital sign monitoring system, and also as a reminder, also the automated system to the nearest or to the doctor. So let's talk about 5G technology. So 5G technology is the generation less standard, and it can supply one 2D and 3D response. So it can be both real wireless one. If you talk about the ISP, will talk about something important in 19 the 1st January 19 was the launch of internet. So when the internet people to people. So now we are living the world of internet human. So in future, it is going to be internet of skills. That means devices connected with devices. So now we are in IoT, transit field, other is evolved field, and other is transfer field. Now we are transit field by we are just starting the 5G, and it is predicted that 2020, some of the European countries will be moved to the evolved field, and later within 2030, the whole world will be transferred to the transit field. So 5G looks slightly different here. Then 5G clear this complexity of the healthcare data transmission. The data connected from the web is various connected to the radio access band, and then it also goes to the 5G machine learning and data by machine learning and data and it dot concentration can communicate with themselves. So I will refer to my next presenter to present the next part of our project.
Hello, my name is Alan Katakura. First, I talk about concept of smart city. As I represented in this diagram, smart city, sorry, smart city is a set of several smart, such as smart people and smart living, using several internet technologies such as IoT and IoT. The set of smarts can be different in each cities, and there is no single form of a smart city. Our discussion on early compare is an area of health, security, and smart care. And in this context, it belongs to smart living. We will focus on smart living and discuss partly on IoT-based technologies for health and smart care. Here I will discuss a SWOT analysis of 5G technology. The strength of 5G technology is its low latency and high capacity. The ability of handle large size data with low latency is expected to enable the rapid execution of medical treatment and data analysis that couldn't be performed remotely before. Weakness, low RF power and energy consumption. More complex antenna needs more power and high frequency of the signal leads low radio frequency, which means it will be harder for the signal to pass through the wall. The opponent promotes the development of smart city and recruits young people to stay in Aizu Wakamatsu. 5G can support and promote the development of smart city development. 5G can support and promote other emerging technology industries. That means 5G is useful for smart city. The threat of 5G technology is security and dependence. The more devices that 5G systems will accommodate cases, it is more vulnerable to cyber attacks. And once the network is disconnected, the IoT that depends on it will also down. The development of internet technology has brought about significant changes in the way elder care is provided. In the traditional form, patients and those requiring care were limited to the location and the number of healthcare personnel. However, with the advent of wearable devices and the development of internet technology, it is becoming possible to deploy medical technology in ways that are more in line with the lives and mobility of patients and caregivers in need. the impact that this will have is significant, potentially resolving sub-problem. For example, the problem of not being able to choose the right doctor for you because choose the right doctor for you due to the location problem or the time-related problem of time-related problem or not being able to increase the frequency of follow-up visits. That's the end of my part. I'd like to next presenter.
Okay, hi, my name is Ben Korea. I'm a first year student in Aizu Wakamatsu. So I describe the current situation in Aizu Wakamatsu City. According to 2030 census, the aging rate in Aizu Wakamatsu City is 31.5%, and the average of aging rate in Japan is 28%. And so this city's aging rate is more 3% higher than the average, so it's a serious problem. Okay, and then there are 250 senior care facilities in Aizu Wakamatsu, but the amount of home care facilities is 41. So it is not enough to cover all elderly people. In Aizu Wakamatsu, home care support center provides a service such as housework assistance and nursing care. There are very hard works, and this country concerns a shortage of workers with home care. So, as shown in this graph, the aging population in Aizu Wakamatsu has been continues to increase. If this trend continues, it will become difficult to provide the service for existing home care facilities. So we believe that we can improve such a situation by realizing smart house with 5G network technology. We focus on Aizu Wakamatsu City because this city has many problems for elderly society in realizing smart cities. For example, the shortage of medical resource and the labor of home care and damage of disasters and bad transportation systems and high rate of aging, high rate of elderly people who lives in alone, and so on. Not only Aizu Wakamatsu City, but some other small region has similar problems. So we promote the smart city for Aizu Wakamatsu, which has these factors.
Yeah, dear team, please note you are exceeding the time.
Okay.
condition of labor for in time and also small scales, which
Is there, I think there is an issue in the audio system. Am I audible to you?
and on system or the device in time. And after is requirements or system by a smart computer and you don't have to worry about our system will just more specific things and our system also provides people
So, okay. Quickly. And here's my slides. I will continue to introduce some technology which could be used in home care and Breakout solutions. In home care, we can develop a robot, which is also part of IoT, to interact and monitor the elderly, provide some assistance for the elderly. And such as or doing some simple work. And we can install the AI neural so that it can chat with the elderly. It will make them not lonely. And after that, and it's also a part of the home care device. It can be the processor and the low doctors access it. You know, in that case, Rook will be a real doctor. And after that, we made a Google survey, and the results show that most people know about 5G and IoT, but IoTs, and recognize that home care is beneficial for the smart city. But here's the problem: people do not know much about the elderly home care and how it works out. To April guests to care to April guests to care about the elderly. This is one of the reasons why we research. And there are some objective reasons that is useful for the 5G home care. Firstly, there are few high buildings in ISU, so that 5G base station can cover a larger area, and the contribution cost will be reduced. And second, too many elderly people living alone is really dangerous and long, and it's really dangerous and long for them. Besides, doctors can take care of some elderly people whose illnesses are not very serious to reduce medical pressure about the hospital. On the other hand, indirect public contributions in as well as city is pretty good thing for citizens. And further thinking about the financial conditions of people, 5G technology can give them a better home care facilities for the other people. The purpose of our research and the most important point is that it will be very happy thing to care about the health of the elderly people.
Yes.
They can make too much contribution. It's time to make them enjoy their old life and enjoy their old life without any worries. This is some reference about our
Yes.
research. Thank you very much.
Yeah, thank you very much for the
Time is not
presentation.
enough. Thank you.
Yeah, thank you very much for the work and then the presentation. It exceeds the time, 8 more minutes. The presentation time is supposed to be 15 minutes. You have presented 23 minutes. That means 8 minutes more you have taken for the presentation, which will be difficult to accommodate other papers. So the participants, please note the other presentations we have scheduled. So please cooperate in terms of timing. Yeah. Any questions on this? Any questions on the research work? Okay, I have few observations.
Yes.
To me, the work is so interesting. The motivation itself to care the elderly people, I'm very delighted to see such kind of work. And the interesting part of this work is there is a SWOT analysis on the 5G. That is also something appreciable when it comes to technology related work. Though the idea comes from the social science, we have taken into the consideration for this. One curious question for this research is, usually the elderly care or elderly care researchers, it focus on the technology. Whereas the real need is they need a human support.
Yes.
Okay, do we have any feedback system for that?
For the human support system, can you please repeat the question one more time?
Yes, I'll repeat. The question is, elderly people need a technology support that is well appreciated. Do we have any feedback mechanism where the elderly person may find it difficult to express to a human instead of a technology? Is my question clear?
No, I didn't get the question properly. Sorry.
We interview some
Can you please finally one more time repeat the question?
Yeah, not a problem. Do you have any feedback system for elderly people in case they have a difficult to access the technology?
Yeah, actually, those kind of devices, censoring devices, is not very hard to functioning. Okay, so there will be some a helping hand who can help them to get the procedure how to function these devices. Then I think there won't be any kind of problem if they can get support from the technician of those devices.
Okay, thank you for that. Thank you for that clarification.
Thank you.
Any other questions from the participants?
And we are apologizes for taking the time. It was a group presentation, that's why it takes time. We
Okay.
cannot, yeah.
Okay,
Sorry about
we are happy to have it, but the problem is we have scheduled other presentation as well.
Yeah.
It will exceed the time limit. Yeah, thank
Yes,
you.
we got
Thanks
the
for
point.
understanding.
Thank you very much for your consideration.
Yes. Let's go for the next presentation. The next presentation paper ID is 3025. The work is neural collaborative filtering and autoencoder enabled deep learning models for recommender system. This will be presented by Arnold and others. We welcome you now.
Okay, hello, am I audible?
Yeah, perfectly audible.
Okay, so I'll share my slides.
Yeah, please. Yes, the slide is visible properly. Please note down the timings. Yeah.
Right. Okay, so I'm the person of Arnold Kofi, and I'm presenting on neural collaborative filtering and autoencode-enabled deep learning models for recommender systems. This work is co-authored by Professor Mohamed Hamada, University of Faizu, and Associate Professor Rajesh Prasad, African University of Science and Technology, Abuja, Nigeria. So I'll walk through the outline from introduction down to references. So usage of smart devices and computers are rampant now, and they've become part and parcel of our lives. And in as much as we use all these things, we visit social media applications, music streaming, websites, and we contribute to information overload on these platforms. However, these platforms, some of them are able to filter out relevant information to users for users to do what they want to do with that kind of information. And some could be as helping users to know what item to buy on an e-commerce site, what to like, what movie to watch, or even the dislikes of the person. Now, I want to put emphasis that the base of these is an AI model driven, and this is what we term as the recommendation engine. And so it introduces us into recommender systems. So recommender systems are actually software tools and techniques that helps users to filter out relevant information from a large pool of content. And the main aim is to personalize the experience of the user, as earlier said, what music to listen to and what books to read, so on and so forth. Then again, the prevalence of these things are based on the interaction or the interaction history the user has made on these platforms. Now, some of these models used in recommender systems are content-based, popularly known ones, content-based collaborative filtering, and hybrid recommender systems. So recommender system actually spans through, multiple fields, from computer science, data science, statistics, marketing, to deep learning, big data, sophisticated machine learning models. And I must also say that industry, for instance, Amazon sales depends on recommender systems. 35% of it is based on recommender systems. 50% of LinkedIn connections also based on recommender systems, and almost 80% of Netflix stream hours, which is saving them almost 1 billion per year, is also based on recommender systems. And even in academics, Association of Computing Machineries recommender system participants are from industry. So recommender system actually can be grouped into two, that is the personalized and the non-personalized. For non-personalized, there's not so much of concentration on it because it seems a bit easier. Example could be like find the top end read books. But for recommender system, that is where the concentration, for personalized recommendation, that is where the concentration is, because it tries to use activities of the user, the history, similarities of items or users to make its recommendation. So some of the models here could be content-based, which actually uses characteristics of items, collaborative filtering, knowledge-based, and hybrid, which combines two or more recommender techniques to predict. So looking at the challenges and considerations of recommender systems in general, obviously we work with data on recommender system, and sample data which can be used as ratings of items, features, contents, social relationship, and even location-aware information. Talking about algorithm would be from demographic, content-based collaborative filtering, context awareness, and hybrid. Actually, there is this problem with recommender systems in general, that is sparsity and cold start. Cold start when there's not so much of information for, a new user to base on to make recommendation, and sparsity when there's not so much of, transactions in your data for you to base on to make a good recommendation, or for you to base on to make good predictions. And some of the employed technologies could range from probabilistic approaches, Bayesian networks, neural networks, genetic algorithms, and fusion models. So what is the problem statement? Our problem here is that there is a large pool of information, and users find it very difficult to find the right kind of information, as well as even content creators finding it very difficult to map the right kind of information to users. And so obviously, recommender system become a basis for us to solve this problem. And even with that, machine learning models have already taken, aspects of these research area, and they've shown well, but most of them are faced with problems of cold starts and find it difficult to find the non-linearity interactions in the data, and even data sparsity as well. So that is mainly why we need to introduce a deep learning model to help solve these problems. So here our objective is to analyze what kind of deep learning models, deep learning model is applicable for creating a multi-feature personal recommendation. And specifically, we are implementing the autoencode and neural collaborative filtering deep learning to improve recommender systems in general. And we'll be analyzing their performance using root mean squared errors and training losses. So our literature review, Aminu Naomi 2021 actually supposed that many recommender systems utilized for solving information overload problems have been done, but a little research have gone into when it comes to deep learning. Again, in the past, they used to use explicit ratings, that is just ratings of items, but currently implicit rating is taking their attention, and Salakutinov made this in his paper 2007. Bayer 2017 also used an implicit model, on feature-based factorization, and he achieved very good performance on his item recommendation. Then 2016 also, used different formats where he used additional information like text description of items, sound properties of music, and even behavior across users. He combined it with matrix factorization to do his recommendation. So collaborative filtering actually is what we will looking into detail, because that's what we will be basing our DL models on. So it actually came into being 2006 when Netflix competition, when they introduced it, and mainly collaborative filtering uses similarities between users and items simultaneously. And again, the similarity or taste of the users is what we calculate the prediction on. And even without requirement for information about either items or users through explicit or implicit, collaborative filtering is able to provide user-specific suggestions, things based on patterns of ratings or usage. Okay, so collaborative filtering can be grouped into two, mainly the neighborhood method and latent factor models. And under neighborhood, we could also have the item-based and the user-based, where user-based is based on similarities of similar users and items are being predicted to. And for item-based is based on the similar items, where these similar items are being used as the basis for predicting to items to users. And for the latent factor model, it's actually puts a user item metrics into a hidden space for the model to work on. So you could look at looking at the diagram at the right side, you could see mixtures of numbers shown into a latent factor space, and the model is asked to determine or perhaps classify them based on the structure or even the values of the item. So basically, that is how the latent factor model works in a latent space. So for latent factor model, an example is matrix factorization, where, as Elia said, it uses one dimension representing the users and another dimension representing the items in question. So this is actually a matrix with these two dimensions, and they are being multiplied. So the higher corresponds between the item and user factors leads to the best recommendation. So this introduces us to a methodology where we are introducing an autoencoder deep learning model. So autoencoder is actually a feed-forward neural network which implements two transformations, the encoder and the decoder. So the main purpose or the objective of an autoencoder is dimensionality reduction and also to minimize errors. So it takes in the input and goes through the encoder part, which transforms the data and it grumbles the data actually into something that doesn't look like the original, actually through hidden layers. And from there, it passes through the bottleneck where it determines which aspect of the data is relevant to go through. And then it gets to the decoder where it tries to reconstruct the data back into the original, back into the original one. So it also does that using layers where each layers contain neurons. And I must also say that the number of neurons at the input should be equivalent to the number of neurons at the output. Specifically, the dimensionality at the encoding, the dimensionality at the decoding should be the same. So when training this autoencoder, this environment we use the hardware of RAM 8 gig. ID was Visual Studio Code. We use Python 3.9.12 and libraries with TensorFlow, Pandas, and NumPy. Then we used Adam Optimizer and Sigmoid and RMSE also as tools for accuracy check. Okay, so the data we use here is MoveLens 1 million data sets, and which contained 1,209 anonymous ratings, and 75% of this data was used for training and 25% was used as testing. The format of the data seen here, the columns, it has a user ID, a mover ID, the rating, and the timestamp. Okay, so for our TensorFlow implementation, the biases were all initially set to 0, and the weights have a normal distribution of normal distribution with mean 0 and variation 0.02. We have 3 hidden layers, and with each of them have 128 neurons. This forward pass that compute the network output is performed, and it actually took an input matrix, which is the user item matrix, as the input. And obviously, RMSE with mean squared error was used for our accuracy check. So I would like to quickly play this video.
Okay, so this is
to see the implementation.
Model for the autoencoder. So at this point, I'm importing my libraries, NumPy, TensorFlow, and I'm also importing class I've already written for the data processing, where I'm using MoveLens 1 million data sets, and I'm using 5% for my testing and the rest for my training. Okay, so I define my model parameters here again, and these model parameters are here. I'm using flags to do the definition, and I'm putting them in the flags. So I'm showing here the number of epochs. I'm showing the batch sizes. I'm also showing here defining my learning rate, and also the number of neurons I'll be using as well. And I'm also keeping logs of the output so that I can display them on my tensor board. Okay. Then again, at this point, this is where the actual iterations go through. So I'm doing a couple of iterations here, and down below here gives us the result. So this is the output. Couple of epochs are being displayed with corresponding train loss, test loss, and mean absolute error. So this is epoch 1, and these are the respective values as well. The other epochs, I'm sure, should be below. Because of how the data is a bit okay. So for instance, this is epoch 2. So it goes down to the 10th epoch. And starting my tensor board, this should be the display on the tensor board. So this is the display of the tensor board. So adhere to the keeping line shows the actual values, and the faint line shows the predicted values. Thank you.
Okay, so I'll quickly move on to the second deep learning model, the neural collaborative filtering. And this one uses the design of neural network to model the interaction of user item features. And to learn user item interaction, it brings in a multi-layer perceptron. And this is an improvement over metric factorization, since MLP, which is a multi-layer perceptron, is well equipped to learn user item interactions function due to its high level non-linearities and ability to learn any continuous function. So the generalized framework is that it employs the input matrices of both the user and the item. These input matrices are fed into the embedding layers, and these embedding layers are now moved. It's a feed forward sampling. So from one stage to another, it moves into the NCF layers where a couple of iterations are done, and the score is predicted against, and it's being compared against the target if the score predicted is what is actually the output expected. Okay, so neural matrix factorization here brings in the general matrix factorization, that is GMF, what we saw in the previous page, and the MLP, which is the multi-layer perceptron. So at this point, it's not just the user and item vectors, but a multi-layer perceptron vector is attached to each of them, okay? And then are being fed also into the embedding layers, and actually it goes into the NCF layer. But at this point, they work independently. Okay, they move into their own direction. So GMF moves into its own direction, and MLP also moves into its own direction. Then a concatenation is done to form the new MF, which is the fusion of GMF and MLP. The reason is that GMF is only for linear kernels, okay, but for MLP, and the main thing why we are bringing in the MLP is just for it to learn the intricate functions. I mean, the complications in the data, and obviously a score is predicted and tested against the targets. Okay, so in training this one, to the same environment was used with the same data set, and as already explained, the model, the inputs to the model are one hot encoded user and item vector, and it's went through the same process as already explained. So I'll quickly play this to for that implementation.
At this point, I am importing my libraries, pandas, TensorFlow, and other classes I have written. So down below here, I'm setting my parameters. I'm setting the data size, the number of people I want it to go. I'm also downloading the Google Lens data from here directly online. And then I do my splitting here, where I'm using 75% of data for the training and the rest 25% for the testing. So this is the actual NCF class written, which contains all the information. So here, I do the assignment of all the model parameters here, and in the constructor, and the rest of the codes are below. So when I run this code on TensorBoard, the output is going to be shown here. Okay, so this is the output, and the deepening line here shows the actual values, and the faint one shows the predicted value. So this actually.
Okay, so findings and discussions are exactly what I explained in the videos. So with the autoencoder came with corresponding, for the number of epochs came with corresponding train losses and test losses with their corresponding mean absolute error, and the results are displayed on the graphs. Same applies to the neural collaborative filtering with train losses, also results shown on the graph. Okay, so in comparing the states of the ART recommender system to other algorithms, for instance, Narayan 2020 used the same data sets for SVD, single value decomposition, and had a root mean squared error of 0.934. The same author used SVD++, he had 0.92, and the same author used K nearest neighbor, he has 0.98. And in using autoencoder at epoch 0 as compared to these models, we had 0.802, and using the multi-layer perceptron, that is the NCF, we had 0.3965 as a root mean squared error. So in conclusion, this research revealed that NCF performs better than autoencoders actually, even though both are more effective than traditional machine learning models for collaborative filtering. And this work improves the commonly employed shallow models for collaborative filtering and opens up new avenues for deep learning-based recommender research. Future research may examine variables and ways to reduce output losses, especially for autoencoder, simply because of its construction and reconstruction, it loses its shape or its data. Thank you very much.
Yeah, thank you for the presentation. Any questions from the audience? Any questions?
Yeah, it seems like no.
Yeah, I think no questions from the audience. I have a few observations and questions. One is about this privacy. When it comes to recommender system, the biggest challenge is privacy and breach of security. What is your stand on this with respect to your work?
Can you please come again?
Yeah, it is about privacy and security on the recommender system.
Okay, this work was actually looking at the best way, or actually trying to improve, especially for collaborative filtering, trying to improve how recommender system can be made well. Okay, so it was mainly about looking at solving issues of data sparsity, solving issues of cold start, and solving issues of nonlinearity in data. That was what this project was more about.
Okay. The success rate of a personalized recommendation system can be experienced with the user satisfaction. Do we have
Okay.
any statistics on your work?
Please, I'm not getting that question very well.
Okay. Fine, no problem. Please address that. Okay.
Okay. Thank you.
Thank you. Thank you very much. We will go to the next paper. Yeah. And anybody has questions? Yeah, Mr. Budaka, let's go to the next paper.
Yes, sure. I think
Yeah.
next paper is also by Zoom.
Yes, the paper ID is 4409. The work is on studies of the cognitive basis diagnosis based adaptive science learning for elementary school students, which will be presented by Ms. Yang and Sang. Over to them. Yeah, please note down the timing again and then present it within the time frame. Did they join? Mr. Udaka?
Seems like they are not in online, like they are not in Zoom, Professor. So
Okay.
they are not in like physically in here also.
Okay.
So, yes.
Or shall we go to the next presentation?
Yeah, I think we can maybe.
Yeah, that is the only option we have now. Yeah.
Yes.
Yeah. The next paper ID is 7566. The work is implementation of personalized learning system in classrooms. This will be presented by Idula Rashka and others.
Yes, they are in here. So
yeah, please give them access.
Yes,
So
I will help them.
Actually, I have your presentation. Sorry.
I hope they are connecting now.
Yes, I
Yes.
was on it.
Yes. Please go on and note down the timing as well. Yeah.
Yes, you can start. I think, Professor, can you hear us?
Yes, I can hear you.
Okay. Yeah.
So hello everyone, I am Rashika and I am from India. So I am a student of ICE University here pursuing my master's. So today me and my team will be presenting on implementation of personalized learning system in classroom. So this presentation mainly focuses on how we can incorporate personalized learning system in classrooms in ICE Wakamatsu or in Fukushima Prefecture. And this is the outline of the presentation. So we know that Society 5.0 is the Japan's vision for future, which is incorporating new technologies like Internet of Things, artificial intelligence, and other things into the industry and across every segment. So as society evolves, the country's education sector is tasked with preparing students to make them equipped with the skills that can enhance and they can survive and lead in a changing society. So in this digital era, students no longer need to memorize every single fact because they have abundance of available online resources and even the accessibility to the online resources is very easy. So our main focus now should be on the emphasis on human skills such as communication, leadership, and endurance. So to transform from the traditional one-size-fits-all classroom, where we focus on providing same learning pace, time, and curriculum to each and every student into the more modernized or digital era, where we focus on providing customization of learning or curriculum is the main focus of this, which we call as personalized learning. So with the emergence of new technologies such as AI and other learning analytics, it provides many opportunities for personalizing the education. Because students will be from different background and everyone's needs and strengths will be different. So treating everyone with the same requirements is a bit difficult even now. So now my team will take over the presentation.
To personalized learning, the centers of so each student have a different, different strengths, and we need to focus for each one. So we need to know the potential of the purpose of personalized learning is to help like every student to research their potential, better optimize their learning experience for each particular needs. So the customization and adoption, the education methods and technology so that the learning process is better suited for each individual learn and they can focus. Okay, now I will do the brief introduction about the recommended changes from the University of Aizu. And also that for the recommended systems, we have several benefits and applications that we are used to formulate the platform. Just like the AI and the NLP and the flexible learning passes and recommended systems, they can provide learning materials and activities for the customized students for their personal and tailored learning activities to just like to benefit their learning incomes, just like grades or test scores. And this also have beneficials for the teachers and students also. That's just like for teachers to create significantly for the effectiveness, just like they can show the time they spend time to looking for materials or also looking for the grades and the suitable methods for the specific children's. And also for the students, the recommended personalized learning system encourage them to study with motivations and also give them chance to access to the system at any time they want and also at any place they can, just like if they have a laptop or tablets. These benefits have helped the students and the teachers both in a platform that they can access with more significantly and more details to help themselves. And also,
okay, I'm going to explain the example of the AI assistant. Welcome to Martha. This system was developed by the university as a project, and this system can convert the lecture material, lectures contents into the series of the short messages. And in the case when the student wants to utilize this, the system will suggest the the course information, fee structure, and so on. Next is a recommendation systems. Actually, this kind of system has already applied in the many applications such as YouTube, Netflix, Amazon, and so on. And this is the algorithm which aims to provide the relevant information to users. If the student can find the item which is relevant to the student interest, the student will run the contents actively. So the personalization is too much the right content of education to right users. Next is a natural language processing. It is one of the research field of artificial intelligence, and it focuses on the facilitating the interaction between machine and humans. Actually, this technology is applied to many ways, such as the improving academic writing, text summarization and paraphrasing, Q&A, and so on. And this technology is applied to the, as I explained page 9, the AI chatbot is adopt this technology as well as the machine learning. Okay, let's see the characteristics and the external effects of the personalized learning with SWOT analysis. Strengths. The student can customize their own learning curriculum based on the student's strength, weakness, interest, and so on. And the system can do the appropriate suggestion to the students so they can identify and prevent the ability gaps, weakness. Because each student has different knowledge and ability level, so the system has to manage each student learning progress. Not only the system, the teacher has to follow each student learning status also. Next, opportunities. For the school, the students can bring up their potential abilities. And for the companies can companies can continue to develop the system based on the education level of the school. Finally, threats. The student information should be kept securely because these data are personal information, and the teacher found that because the teacher has to manage each student's learning progress, the teacher's workload will be increased.
Okay, so I will explain this part. Technical diffusion analysis, we need to think about the adoption cost. So in our case, we will think that this project will be conducted for a student of University of Aizu. So the students will not earn the money, and also, but it will be needed to have some tablets or computers. So it will cost around 200 euros for tablet approximately. For the state, our project is to help the student and the society and the professors. So we think that we will not take any type of feed, but can cause, if you use so much the tablet or computer, can cause eyes problem with the eyes. The capability will be enough for the Aizu schools. In science, schools in Aizu are small and have not so much students, so it will be not a problem. For the usability, I would say our design is think for students that are young, basic, so they need to know how to use this tool. And basic, if they need some help, we can probably through a video or explain or some manual how to use the tool, but it will be not difficult at all.
the fish system is like to we will use AI to learn and for learning analytics. In the other case, for application, the way to learning right now in ICE Japan is a company in Aizu Wakamatsu is trying to develop a personal like creating a model in metaverse for helps the students with disability. So it's a new project that Aizu is trying to take. Integration is difficult to consider the integration in this case because it depends of each school for each professor, because some professors they don't wanna change the traditional way to teach, or some schools they won't follow traditional way, so they don't want to change. So in this case, it will be hard, but probably in our case, it will be easier. For legal competence, most of the students don't have 18 years old, and they need the consent of their parental consent to use computers and tablets. Security and privacy, as we know, in these days, there are some attacks in computers, so always it's need to be careful to protect our service, and most because these students have they don't have 18 years old, so it's important to protect the privacy data. And for social and cultural, finally, there are no cases that Aizu Wakamatsu try to reject the technology. On the contrary, they are like try to increase projects like Accenture.com that they try to create a smart internet smart city in Aizu Wakamatsu. Thank you.
Next, we'll talk about technical feasibility analysis of our personalized learning system. And first, we'll evaluate the hardware and software requirements for this term, just like for teachers and for the students. They both want to have some, just like the personal tablets for them to help them to access to the platforms. And also we have some beneficial outcomes of this system, just like the short time for the teachers to save time for them searching materials, and also improve the students' learning outcomes. And they can help the students to access to this pattern at any time with any places. And also when we want to use this personalized learning system, we are also compared with this in the already used system and to the global market or any that's or to search for the experience feedback from the students and the teachers who have already been or enrolled in the same system that the experiences. Finally, we will consider about the cost of developing and maintaining the system. For the cost time, we will think about the most part will be developed by the students of University of Aizu. And also to maintain a system just like this is not a hard skill program. It was called KB by something just like easy. Okay.
There was a survey conducted on the implementation and usage of this personalized learning system at University of Aizu. So most of them were welcoming to include new technologies like converting text to audio or something like that, which they can feel free to use. Whoever want to listen the lessons instead of reading the text, it will be useful for them. And also most of them supported the incorporation of recommendation systems, which provides the courses based on their interests. But some of the challenges in this are it may be difficult to implement in short period of time, and also this can create inequalities between students because their learning paths, if they totally differ, then it can create inequalities. So these are some of the results provided from the survey. And there were also some suggestions which were taken from the students and teachers. If most of the students feel that if teachers know what the goals of the students are, they can probably be more confident and effectively improve their teaching, and even students can have a more effective way to learn. So in conclusion, we believe that education systems and establishments can benefit from new technologies so that they can deliver education more effectively. And this personalized learning system can keep students motivated because they know the path of their learning and their goal for education. So these tools just support teachers in their efforts to teach their students in classroom, and they do not necessarily change or challenge the teacher-student relationship. So with this, we end our presentation. Thank you for listening.
Yes, Rashika and team, thank you for the presentation. It is a good work. I found two challenges. One is the results which you are showing is the responses are in terms of number, it is only 22 responses.
Yes.
Number one. And the second one, as personalized recommendation to the classroom, it is a burden to the teachers as well. Okay, when we have personalized recommendation for each students, and then the outcome evaluation is a very difficult one from the teacher's perspective. And you also addressed the same in the SWOT analysis. When it comes to threats, you mentioned that it is a burden for the teachers. It's in terms of workload.
Yes.
So how do we manage this research work to address that gap?
So maybe we cannot incorporate a personalized learning system totally into our education system, but we can take it partially, like providing extra materials like fundamental materials for the students who require basics or something like that, and providing some more extra materials for advanced level and solving those in that terms. And some others, and I think recommendation systems is not a problem for teachers. It's just for students to help to join a course with me.
Yes, it is helpful to students, but when it comes to evaluation of that learning, evaluation of their learning with respect to a particular course, that becomes little tough to the teachers. That is the perspective now. Now, as far as the students is concerned, they have a flexibility, they have an openness to do. But when it comes to teacher to assess that learning, it becomes difficult. That's what my view on this.
Yeah, but maybe in the terms of if the student's goal is to learn something, then if he is able to reach his or her goal, then we can consider that through a formative or summative assessments which are suggested through AI or something, that will most probably be helpful to evaluate.
Yes. I mean, it's a new perspective. Thank you for this wonderful work. Any other questions from audience?
Are there any questions? Yeah, seems like no questions in here.
Thank you, Professor.
Yeah, thank you. Yeah, we'll go to the next presentation.
Yes, I had this drop. Yes. So paper number 5, the presenter is here.
Okay, that means the paper ID is 4409.
Yes, 44009.
Studies of the cognitive diagnosis based adaptive science learning for elementary school students.
Yes.
Yeah. Please go on, and then please note down the timing.
Yes.
Please strictly follow for that. That will accommodate other 2 papers as well.
Yeah, sure. Yeah. Yeah. Okay. Just do it. Number 2. Yes, Professor, can you see the screen?
Yes, I'm able to see the screen.
Yes, sure. Okay.
Yeah, please go on. Please note down the timing.
Hello, Professor. You can hear me?
I think, Professor,
Hello?
can you hear?
Yeah. Hello, Professor.
Yes, I think,
Okay.
yes.
All right. Okay. Hello, everybody. I'm Zheng Yongyi, come from Taiwan. I study in the University of Chengkong. Okay, now I think I'm happy. I'm so happy to hear present my research. Because from Taiwan to Tokyo, then to here is very far away. All right. Okay. My research is study of the connected direct-based adaptive science learning for elementary school. In Taiwan, we have a sentence say, the math is science mother, and the science is a power of the country. So we feel the science is very important for elementary, junior, and senior high school. So my research. Okay, so in the teaching in management, we think the e-learning or poly-learning will teaching methods are and will affected by technology. For the COVID-19 and COVID-19, the student was at home, and all the teacher may be at home or in school, but the student and the teacher are not together. So we provide the study for sure that in terms of teaching and learning. Adaptive learning is limited because the teaching lets the machine of individual decision. So in addition, for technology assist adaptive teaching, the use of teaching strange based on consent diagnosis also based to a lack of sophisticated data and to research. So we feel it's very interesting. So we develop the system for science learning. Okay, so the limits of the above dichotomies may affect the depth of learning and the teaching. Then our research question is concerned learning focus on the interaction between the learning and the student dynamics. So we could a series of physical studies to impose and the impact of some study in student learning and the teacher how to teach in the technology for students. All right, so first we develop a concept to how to know the assessment system to the student. And the second, the real-time connect directly is integrated into e-school bag. So we use the e-school bag system to student, maybe he can learning at home or in school for native assessment and online to use the system. We want to know how the system how to stop the student learning or better or no. Okay, let me show the picture. The student is in my school in Taiwan. Okay, now the student follow the system to how to learn the science. And you can see the photo and the CY is mean how to is mean the science system.
So you can see the login. You can see the login, and you can see the photo. And because it's for traditional Chinese, so okay, it's I can show the web tonight today, but it's you can see the photo now. Okay, right. So as for the research math of event research, we think we adopt simple graph convention and how to assign connect alignment. So in root and math about we explore the aspect of learning design and with sufficient concern, which enable to us to explore how to compare the approach straight and the different learning assessment. Okay, so in the following of the results of the three in-test study in this study, the first in study, we discovered that the mean recognizance of the computers display system developed in this study are 97%, 99%, 97%, and 99%, 98%. This system can invest and automatically divide the types of the mistake that the student made. And then second, in study 2, the result shows no significant difference between the two groups about the e-learning and the traditional learning. But however, analysis of a job study show that learning and the STEM device of the experiencing group was supervised to those of the control group. Despite having a low pre-test score, the experimental group still produce a high post-test score than the control group. And then finally, in the study 3, the result remained that the adaptive learning students exhibit learning performance and misconception correlations and surprise to those of the student of the control group. So we think about the system is better than the traditional learning. Okay, based on the above results, we understand the aspect and the strength of cognitive device applied to adapt science learning. So in our research, we about a process of formation of the concept by containers and the question of the cognitive component in game-based learning or the e-learning. Maybe we can use and the cognitive compete with the IT agreed and the other possible future. Maybe we can use in our research. Okay, so this survey of the studies helps to express and the evolution and the transformation of the in elementary school students' knowledge, his learning, and so we believe the research in the future, the evolution and the development of cognitive the growth and expecting to have important reference value. Okay, that's my research. Thank you for your lesson and welcome to Taiwan. For us to see you. Okay. Thank you, Professor.
Thank you for the presentation. Any questions from the audience?
So I have
So, how is the engagement of the student with the system? Is it positive? These are traditional group and the e-learning group. Yeah. So they are enjoying. And in the same time, a group to e-learning and a group for traditional learning.
Okay. Any questions? Any other questions? Yes, I have only one question. Do you have any interesting statistics or results based on your research? Interesting aspect, something which you can highlight.
Okay. Interesting findings of your research. I think that it, yeah. So what are those? What kind of? Yeah, what kind of interesting findings you had in your research? 3 months. And so I can. So, the professor said, what kind of interesting findings you had in your research? I found, maybe I think that we can use more in e-learning for our learning. Traditional, yeah.
Thank you. I'm very happy that this work goes to elementary schools. I'm happy about this.
Yes, there's one question from all right. Okay, so we have translated. Yeah, it's okay.
Okay. Thank you about the presentation.
Okay.
If you have no questions, we can proceed to the next presentation.
I think no question from.
Ms. Budaka,
Yeah.
Shall we go to the next presentation?
Yeah, sure. Let's go.
Yes.
Uh,
Yeah, the next presentation, the paper ID is 8213. The paper titled on a novel movie recommendation method based on clustering by genre. This will be presented.
Hi.
Yeah.
Yes. Hello to everyone. May I share my screen now?
Yeah, please.
Okay.
Yeah, your slide is visible now.
Okay. May I start now?
Yeah, you can start now. Please note down the timing.
Okay. Well, my name is Julia Sevaslidou. I'm a PhD student at the Department of Organization, Management, Marketing and Tourism of the International Hellenic University, which is located in Greece. My partners are Mr. Panagiotis Kargidis and Mrs. Evgenia Papaioannou. I'm going to present your research work under the title A Novel Movie Recommendation Method Based on Clustering by Genre. Here is the table of the contents of the presentation. We'll start with the introduction and the motivation of our work. Statistics revealed an impressive trend related to the video-on-demand films. Possibly it's the COVID period that affected and increased the film industry to this level. With shutdowns occurring throughout the globe, consumers relied on film on demand and streaming video for entertainment. The number of video on demand entertainment users increased by 31% in 2020, and the revenue climbed to 61.8 billion. Online video on demand systems are arising every day, and it is a mandatory task for them to provide a top-of-the-art movie recommendation system to their customers. And it's crucial for such an online system to predict quickly and precisely the style of movies that the user would like to watch, and then recommend one that belongs to this specific style. Netflix supports that over 80% of what members watch comes from recommendations. The movie industry companies using a recommender system approach gain the advantage of increasing their profits through improving the experience of their users. So the recommendation systems are responsible for filtering the information and providing the most relevant content to the users, improving their experience by reducing the information volume that is delivered. The most dominant recommendation method is the collaborating filtering. The collaborating filtering method exploits the ratings given by other users and recommend items to the active user. The algorithm is based on the ratings of similar users. It has two main steps. At the first step, it computes the similarity between the active user and all other users in the system. And at the second step, it develops recommendations for the active user according to the first step. However, there are challenges that researchers must face when utilize this method, specifically the scalability, the accuracy, and the cold start problem, as they were also mentioned by the other presentation earlier. As the number of users and movies of an online movie system like Netflix increases dramatically, the scalability problem becomes more urgent than ever. The collaborating filtering procedure demands heavy computations. By increasing the number of users or the number of movies, the computations grow non-linearly. On the other hand, the collaborative filtering fails in precision when the number of users and movies grows. So our goal is to provide an improved framework for movie recommendations with upgraded accuracy and running speed. In order to accomplish our goal, we divide the problem into smaller problems because we know that the solution for a smaller problem is usually faster. The collaborating filtering method, in order to recommend a movie to a user, takes as input the ratings of all users for all movies, finds the most similar users to you, and proposes to you the movies that these closest users like. Our proposed method divides this process into two parts, into two steps. It takes as input the ratings of all users for all movies and finds the style of movies that are preferred by the user. Then it may propose a movie from the pool of movies that belong to the preferred categories. This way, we shorten the data that should be compared for similarity. So for part A, a basic implementation is to use the K-nearest KNN algorithm to compute the similarity between the active user U, preferred style of movies, and all others all other user style, and then recommend the most common one. We improve this step by first applying a clustering step. We cluster all users according to their preferred genres and group the most similar users together. Our goal is to quickly assign the user to this cluster of users that he or she shares most common tastes and preferences of the style of movies. Then we can search more easily, quickly, and precisely for candidate movies to recommend. So let's see our implementation. We developed a new procedure for predicting the movie genre preference score for each user, not only faster, overcoming the scalability problem, but also with higher precision. We compare our results by using the most dominant collaborating filtering algorithm, the KNN. This is a three-step procedure. The initial data set consists of movies and their genres and user ratings for movies. In step one, we transform the movie ratings to their respective genre ratings. In step two, we cluster the users of the system according to the mean rating on genres. And in step three, we run the KNN algorithm for every cluster of users. So in step one, in order to produce table 4, we first need to compute table 3 by applying inner join operation of the first two tables. Then we aggregate table 3 for computing the average score grouped by user and genre. In step 2, we cluster the users of the system according to the mean rating on genres. For each user, it is assigned a vector produced by his mean rating for each genre. So for a data set of n users and m genres, we have these vectors that are shown on the slide, where RIK denotes the mean rating value of all rated movies by user I belonging to the kth genre. We used the k-means algorithm in order to cluster the users according to their preference on movie genres. K-means takes as input the number of clusters to be generated. We tested it for different number of clusters ranging from 1 to 100. As we can see, there are some cases that the value, not a number, is present. This may occur for the cases that the user has not rated any movie of the specific genre. But the standard k-means algorithm needs the coordinates of all the dimensions. So there are several methods to handle these unknown values. For us, method 3 and 4 are not applicable, so we continued our experiments by substituting these values with the 0 value and the mean value from genre rating. For every cluster of users in our dataset, we run the KNN algorithm in step 3. The prediction RUI is calculated by the formula shown, where SIM is the similarity measure to be used. We use the mean square difference similarity between all pairs of users, which is defined by the type shown. And we use the default value of 40 neighbors, which in many cases, in many clusters, cover the whole set. So for our experiments, we implemented one standard collaborating filtering algorithm that uses the KNN algorithm to predict the genre rating values. And our new proposed algorithm that first applies clustering to the users. We named it k-means KNN. and then predicts the genre values by using the KNN for each cluster. And we compared them about their accuracy and the runtime. We also used the movie lens dataset, which consists from 600 users, 10,000 movies, and 100,000 ratings. Every user has at least one rating, and the rates are between 1 and 5. The movies are categorized into 19 genres. Each movie may belong to more than one genres, and in this case, the movie rating counts for all the genres that it belongs to. We split the rating data set into 80% of training set and 20% of test set, and we used 5-fold cross-validation. For metrics, we used both runtime and accuracy to estimate our proposed method. Runtime is the feed time in seconds for each split, plus it's the testing time in seconds for each split. And accuracy is estimated by computing the root mean squared error and mean absolute error between the predicted genre rating and the actual one. We compare, for the results now, we compare the proposed cluster collaborating filtering algorithm K-means KNN with the standard one. The results are separated into two categories: runtime results and accuracy results. K-means clustering was experimented for different values of clusters, as I said earlier, ranging from 1 to 100. Actually, the number of one cluster means that there is no clustering, and the traditional KNN algorithm is executed in this case. Figures show the relationship between the number of clusters and the runtime. We present the results for two cases by substituting the not a number values with 0 and the style mean rating. We conclude that the method of handling the unknown values does not affect much the speed performance, but the 0 method has slightly better performance. By both metrics, we can see that the runtime improves as the number of clusters increases, and it tends to stabilize after a number of clusters. Root mean squared error and mean absolute error also improve. 0.75 is the RMC for one cluster, which is the traditional KNN, to 0.56 for 91 clusters. After this number of clusters, the accuracy does not improve anymore. The same results about accuracy are obtained by the mean absolute error accuracy metric. Both metrics present a slightly better accuracy performance when we use the 0 substitution method for the not a number values. So our conclusions, we can see that film and series watching is considered to be a top trend in our days. Online film on demand systems are arising every day, and it is a mandatory task for them to provide the top-of-the-art movie recommendation interface to their customers. It's crucial to predict quickly and precisely the style of movies that the user would like to watch. Our method results showed an important improvement on both the speed performance and the accuracy of the system. And since the topic is that important, we will continue this work by experimenting with more clustering and collaborative filtering algorithms. And we will also extend our work to part B, as shown in this figure, to recommend movies now from the genre pool. Thank you for your attention, and any questions, I would be glad to answer.
Yes, thank you for the good research work. It's a real pleasure to see such kind of research work. You know, movies are real time. We get really engaged with that. So collaborating such work which takes extra advantage in terms of understanding the research. I have a couple of questions. The clustering, do we have any dynamic clustering based on a trend? Say, for example, a movie released in a month before, which gets so popular, say the Avatar, for example.
Yes.
Do we have a provision for adding into the dynamic filtering?
Not yet. Not yet, because it's our first implementation of clustering, but we have plans for many more methods. One of them is also the dynamic clustering.
Okay, that's good. What is, according to your data set, too extreme? What is overfitting? What is underfitting? That means you have some clusters, you have set of data. Is there any specific data set, specific film or genre which will not fit into your research?
Where in our data set there was two cases that no genre at all was applied. So we just removed it from our data set.
Okay, fine. I request audience, do you have any questions?
Do you have any questions? I think, Professor, no, nobody has any questions.
Nobody has a question now. Yeah.
Yeah.
Yeah, thank you very much. We wish you success for the future research.
Thank you very much.
Yeah. Mr. Budka, shall we go to the next presentation?
Yes, sure.
Yeah. This next paper, paper ID 9096, titled as An Interrogation of Android Application Based Privilege Escalation Attacks. I would like to add a special note on it. I am also one of the author into this. Over to the presenter, Mr. Arul Kumar.
Is my screen is visible, sir?
Yes, it is visible.
Thank you so much. Is my PPT is visible?
Yes, sir. Please go ahead.
Yeah, one second. Yes. Very good morning here. Welcome you all for the presentation. I'm Dr. Arul Kumar. I'm working in the Christ University. And here, before going to my presentation, I would like to share a scenario here. So in a network, there will be an admin or a server who will be taking care of the entire network. The network will go smoothly when the users are accessing the network as a user under the administration, like the server. Like now, when hacker enter into the network, there may be a chance where a hacker can find a vulnerability in the application. It can be a mobile application or the web application. In my case, I'm just considering this as a mobile application. If a hacker found there is a vulnerability, like software vulnerability in that application, there may be a chance where an hacker can try to claim as a admin. So that if a hacker acts like an admin, he can do any kind of modification, like he can read the data, update the data, and delete the data. So this is what usually we are referring it as a privilege escalation attack. Now, with this short introduction, we are going to see the research work that we have done for this conference. And these are the topics that I'm going to cover in this presentation. And introduction. So we know that Android is very most widely used operating system among the consumer. In the market share, almost 74.13% is Android is dominating. And 2 days back, even in our country, we have released a new operating system for a mobile operating system. So the popularity of the Android platform has increased. Maybe it is actually leading to cyber crime also. And so this privilege attack and the Android application, in other way, it is giving access to unauthorized access to sensitive data. Maybe by the hacker, they may find the weakness in the design, or maybe there is some error in the operating system. If the user is not installing the right update at the right time, there may be a chance where hacker, say a user, can undergo into a privilege escalation attack. So attackers, they use the malicious application to exploit the vulnerabilities in the application. And next, my research work, we're going to examine the study of the Android security domain and the attacks, and some detection techniques, how to detect this kind of attacks, and some threats and measures. For example, what is privilege escalation attack? What are the different types of attacks are there? How to define those kind of attacks? We made a simple survey here, and this research work can help the researchers to utilize the information to understand about the Android security. Next. So in the literature review, I have given some papers where we got some sufficient information to proceed further. The first one is in this first research work, the author has identified different categories of the attacks, especially related to the Android system. Here, the author has classified into hardware-based attack, kernel-based attack, hardware abstraction layer-based attack, and application-based attack. And in the second work, the author has given an introduction about how the Android application may access the smartphone resources. Like when we install an application, what kind of permission it is asking to get the user detail. And the author suggested that the developer must disclose the application permission when they are installing the application. And in the third research work, we got an information about how the Android operating system relies in the privilege separation to keep the separate between one and another systems. Okay, so with this three base work, we are going to start what kind of attacks are there. Like we have found that the attacks may be in this different types of attack, and these attacks are based on the device that were attacked. For example, it can be a different application on the same device, but it is on different layers. For example, hardware based, kernel based, and hardware application abstraction based, and then application based. And when it comes to application based attack, as I mentioned earlier, the hacker can try to get the resources. It can be even the memory, CPU usage, data, and other storage information also. Now, what is privilege escalation attack? As I mentioned earlier, this attack is mainly used to use the privilege escalation vulnerabilities that is frequently documented. And even there is a term, actually, dirty cow. It is referring to a vulnerability in the Android operating system. We can see this kind of attacks in the Linux versions also, for example, version 5, 6, and 7. Now, there is one kind of privilege escalation attack. It is nothing but horizontal privilege escalation attack. Here, the user will gain access to account with privileges similar to original account. For example, there is a user, so he will try to get privilege of the other user. For example, someone can access to someone else's information. And next, when it comes to vertical privilege escalation attack, the gaining access to attack with more privilege. For example, I can see in the image, a user is creating a scenario that he is a super admin of the network. So this kind of attack can execute any kind of criminal code by using this kernel level actions. Next, we have identified some factors in the growth of the malware. What are the factors I have given here? But the first one is code injection attack, and the second one is runtime information gathering attack, and third is man in the middle attack, and fourth, dirty cow attack. Now, accordingly, I have given the what kind of category it falls, and what is the vulnerability exploited, and what is the strategy they use in order to launch this attack, and what is the security measure available according to this attack. Let me take one attack, code injection attack. So in this attack, they use a third-party library as a strategy to launch the attack. And when it comes to RAG attack, they use malicious applications to launch this attack as a strategy. Like in the man in the middle attack, they use a trusted host to launch the attack. And in the dirty cow attack, the attacker first establishes a link. Like they may send it to the user, and then they will launch the attack. Now, there are some fundamental ways are there to identify the hazardous contact, a program, and to stop it. For example, there are different detection mechanism we have identified. The first mechanism is static approach, and then second is dynamic, and third we have a very good approach called hybrid approach. Let me give what is mean by static approach, dynamic approach, and hybrid approach. So before the program is executed, the tool may detect what kind of malware it is or what kind of risk is there. That is called as static technique. And in the dynamic technique, it may spot the malicious activities as it occurs. So dynamically, it will monitor. These are three mechanisms we have identified in order to identify the attack. Next, here, what kind of permissions the Android uses mechanism? We have identified three mechanisms. One is discountry access control, and second one mandatory access control, and third is Android permissions. Now, let us see some tools we have identified to prevent these kind of escalations attacks. So first tool is Apex, and second one is Xmandroid, and third is AdSplit, and finally we have Adroid. So these are the tools we have in order to prevent this kind of privilege escalations attacks. So in this table format, I have given it as what kind of tool it is, how it is working, what kind of application and library it is related, and user confirmation in privilege section, and threats that is found. And I have also given the limitations of these kind of tools here. Let me take the first tool, the Apex tool. It will prevent the personal information leakage from the system resources. So this is what it does. The next one, Xmandroid, will detect the escalation attacks, and third, AdSplit, it will protect from click-based fraud attack. When the user is using their mouse, it will protect. And the fourth, finally, we have here is Adroid, which will which is related to vulnerable advertising-based network. So we have four CAMS tools in order to prevent these kind of attacks here. And next, what the future scope of my research work here is, here Android application developers can restrict the number of permissions if they are installing any application. And then next, developer can adhere to the security now. For example, we have SSL for secured communication, and then we should use the strong password by combining alphabets, numbers, and symbols. And user needs to confirm the rights requested by the application. If it is not necessary, for example, some application may request your SMS, call records, contacts. So you should be very careful whether it is needed by the application or not. And Android user should use only the application that can be downloaded through the Play Store. Why I'm mentioning this particular point? If we are downloading this APK file through the third-party website, that may be the file may be malfunctioned one. For example, they may use any extra binders to bind the malicious code with the original code. So it should be very we should be very careful when we download any APK files. So we personally suggest only to use the Play Store, especially for the Android platforms. The inability to inspect the programs downloaded from outside the sources will put us in the risk. And let me say the conclusion of my research work. And Android platform security flaws needed to be fixed, and we have more updates whenever the developers found an issue in the platform. The main goal of the study is to give an overview of the current Android system. Like we have identified what kind of attacks are there, and what are the tools are there, and what kind of approaches are there in order to detect the privilege escalation attack. And researchers are working in the new ways to define the Android system. There are and this particular article, so we have analyzed different layers of the attacks also, and we have given the result in the form of tabular format. And as a consequence, there may be some research gaps for these tools, and still it needs a comprehensive solution. And the continuous research work and innovation are needed to deal with the most recent attack. And I have given the references here. What do you say?
Thank you for the presentation, Dr. Arul Kumar. Over to you, the audience, for the questions.
I think there are no questions from here. Yes, most of the participants went already home because there's a huge snowstorm in Aizu. So yes.
Yes, sir. Thank you. Thanks for the opportunity. If there is anything, I can answer.
Mr. Budka, is there anybody who is asking question?
From the audience, no.
Okay. I mean, it will be a fallacy if I ask questions on the paper whom I have been an author. Okay, that's what I'm waiting for others.
Yeah, so it seems there are no questions from here.
Okay. Okay, thank you very much. With this, we come to this end of this particular track.
Can you stop sharing, sir?
Yeah, please. Yes, sir. Please turn off your mic as well. Yeah, with this, we come to this end of this session 6, where we have presentations on IoT, autonomous vehicle, recommender system, and cybersecurity. Thank you very much for joining. With this, we come to an end of this.
Okay, so I'll be stop recording in here. Okay.
Yes.
Bye.
Yeah, bye. Thank you.
Bye.
Thank you too.
Bye.